The cybersecurity landscape is entering an era where time itself becomes the ultimate battleground. Man, that quote from Brennan Lodge, a fractional CISO, really hits the nail on the head, doesn't it? We're literally standing on the edge of this massive shift. We're moving away from human response times and plunging headfirst into a conflict governed entirely by machine speed.
Welcome, everyone. In today's Explainer, we are unpacking a seriously high-stakes topic, the 2026 cyber arms race. Look, AI is no longer just this cool experimental tool. It's actively maturing into an operational weapon. And because of that, the gap between an attack launching and a defense responding is just collapsing. Today, we're going to explore exactly how this transformation is playing out and how defenders are fighting to keep up.
Okay, let's dive into this. Here's our roadmap for today. We'll be covering the 2026 cyber arms race, AI-powered offense, deep learning and SOAR, building trust with XAI, the NIST AI framework, and finally, the next generation.
So, Part 1, the 2026 cyber arms race. Industry experts are circling 2026 as a major, pivotal inflection point. Why? Because AI agents are going to take network intrusions that used to take days to unfold and compress them into mere minutes. Think about that. An entire corporate network could be totally compromised in the time it takes you to brew a cup of coffee. We're talking initial access, privilege escalation, lateral movement, data exfiltration, the whole shebang, all happening completely autonomously. No human attacker needed at the keyboard. And those rare, high-effort, zero-day exploits? They're going to become scalable assets deployed across cloud infrastructures and supply chains like wildfire.
That brings us to Part 2, AI-powered offense. Let's look a bit closer at how attackers are actually doing this. The really crucial thing to understand here is that AI isn't just helping bad actors write malware or automate phishing campaigns anymore. The AI systems themselves are becoming the attack surface. Threat actors are going to actively exploit prompts and agent instructions to basically trick AI models into doing harmful things. And the wild part? These attacks won't even look like traditional code exploits. They might just look like a clever, well-phrased request that slowly shifts how an AI agent behaves. Experts are calling these -day vulnerabilities because the exploitation happens before defenders even realize that these prompts or these slight behavioral changes are security boundaries that need protecting in the first place. Which leads us to Part 3, deep learning and SOAR. But if attacks are taking just minutes and hackers are exploiting the very AI we rely on, how in the world do human defenders keep up? Well, security orchestration, automation, and response, or SOAR platforms, are going through a massive evolution to solve exactly this problem. Traditional SOAR systems were pretty rigid. They relied on rule-based correlation, batch processing, and fixed workflows. They were essentially just looking for known signatures. But next-generation, AI-enhanced SOAR systems, they are a total game changer. They use graph-based data models to map out complex relationships, real-time streaming to process telemetry the second it happens, and adaptive decision trees to dynamically orchestrate a defense. So instead of just flagging what happened after the damage is done, deep learning actually helps these systems understand why it's happening, figuring out the attacker's intent as it unfolds.
So how do we actually build one of these advanced defensive tools, like a deep learning malware classifier? It generally follows a structured 5-step process. First up is data collection, gathering huge labeled datasets of both nasty malware and safe, benign software from places like VirusShare. Step 2 is feature engineering, which means extracting the important clues like raw byte sequences, API calls, or specific system behaviors. Then, Step 3 is model design. This is where we bring in heavy-hitting architectures like convolutional neural networks, or LSTMs. Basically, these are highly advanced pattern recognition models designed to chew through all that complex data. Step 4 is evaluation. You have to test the model with totally unseen data to make sure it hasn't just memorized past attacks, but can actually spot brand new ones. And finally, Step 5 is deployment, pushing it out into endpoint detection tools or live cloud scanners.
But right here is where we hit a massive roadblock. You see, deep learning models are incredibly complex. They're often called a black box. So think about it. If an AI system suddenly flashes a massive red alert, but your human analysts have absolutely no idea why the machine made that call, how can they trust it enough to take action in a high-stakes, high-pressure environment? And that brings us to Part 4, building trust with XAI. Explainable artificial intelligence, or XAI, is the absolute critical bridge here. XAI uses techniques like SHAP, which stands for Shapley Additive Explanations. Now, what SHAP essentially does is highlight the specific characteristics that actually drove the AI to make its decision. It completely opens up that black box. And this does two absolutely vital things.
First, it lets human security analysts actually review, validate, and most importantly, trust the AI's alerts, which cuts way down on alert fatigue. Second, it helps organizations stay out of legal trouble by meeting strict compliance mandates for explainable decisions, like the rules you'll find in the GDPR. So transparency isn't just a nice feature to have, it's a hard operational and legal requirement.
Let's move on to Part 5, the NIST AI Framework. As all this technology is racing forward, the U.S. government is actively rushing to put structured defenses in place, specifically with the preliminary draft of the NIST's Cybersecurity Framework for Artificial Intelligence. And this brilliantly illustrates how defense is organized around three core focus areas. First, secure, which is all about locking down AI systems and their underlying supply chains. Then defend, which means actively using AI to boost your own cyber defense capabilities. And finally, thwart, which is focused on building up your resilience to block entirely new AI-enabled threat vectors. It's really a comprehensive way of looking at AI as both your biggest asset and a potential vulnerability.
On a practical level, NIST proposes layering these AI considerations directly onto their 6 existing core functions. Let's run through them. For govern, it means clearly communicating the known limitations of your AI. For identify, it's about tracking entirely new classes of vulnerabilities. Over in protect, it suggests things like setting up completely separate identities and credentials just for your AI systems. Under detect, it's establishing procedures to monitor every action taken by the AI. For respond, you need to preserve the decision chains of your AI system so you can unpack what happened after an incident. And finally, recover, which involves rigorously testing your AI model datasets for poisoning to guarantee they are actually safe to restore. It is a fundamental update to standard cyber hygiene for the AI era.
Let's wrap things up with Part 6, the next generation.
So how is the industry pipeline actually preparing for this intense 2026 reality? Well, if you want a real glimpse of the future, just take a look at the final year projects of today's cybersecurity students. We are seeing some incredible grassroots innovation happening right now. Students are out there building AI-powered intrusion detection systems using deep learning. They're designing IoT deception honeypot networks, which is essentially setting up these fake smart devices to bait, trap, and study attackers. They're engineering real-time deepfake detection systems that use machine learning to verify if audio and video are authentic. And they're even creating gamified bug bounty simulation platforms. This just shows you the sheer scale of the talent and innovation that is being cultivated right now to step onto this brand new battlefield.
Which brings us to our final thought for this explainer. The technology is advancing at breakneck speed, the regulations are trying to adapt, and this amazing next generation of defenders is stepping up to the plate. But the fundamental challenge remains. In a world where cyber attacks compress into mere minutes, is your defense operating at human speed or machine speed? It's a question every single organization is going to have to answer before 2026 arrives. Thanks so much for joining me on